Let's go. So we'll be designing a very simple circuit in a simulator called Tinkercad. But before we get started, let's just address some basics. So first, we should know what's a breadboard. Breadboard is a kind of a prototype or a sandbox environment, you can say. You can purchase it online or offline. It should be readily available, and it usually comes with a bunch of wires. But if not, then you will have to get those wires separately. And then some color diodes. So diode is a it's this is a color diode LED. A diode is an electronic device that conducts the current only in one direction, and the color LED diode is able to produce light on certain voltage inputs. So every color will have its own corresponding voltage range when it can blink. So if you buy these diodes, you will usually get this chart with you. So let's say for green it's 1.9 to 4.0. So below 1.9 it won't be blinking, and above 4.0 if you give it the voltage, then it might just burn because that's too much of voltage to handle for the green diode LED. Similarly, there are voltage ranges for violet, blue, yellow, red, orange, everything. And then if we and what you will need is a device like this, variable power supply voltage, variable voltage power supply. With this, you can vary the voltage that is provided to the circuit. So let's go ahead and just design this simple circuit. So this is Tinkercad. So instead of buying all this, I'm just using an online simulator. So it's up to you whether you want to get these things offline and then do a hands-on, or you can simply do it on a simulator. In college, in our laboratories we used to have all this available. So we used to do hands-on, but here I'm now just using a simulator. And also in real world projects, in real world industries, similar simulators are used a lot. So simulators have advanced a lot. So simulators are used for the majority of the activities. So we'll just go ahead and design this simple circuit. So we'll just use the breadboard first. So in breadboard you may see there are rows and there are columns. So the rows are interconnected. As you can see, the rows here are interconnected with each other. You can see the green bubbles. So whenever you are connecting any diode or anything, you should always connect it between two different columns. So if you connect it between the same row, that means you are not creating any voltage difference. So essentially the circuit won't be formed. It won't be a working circuit. So whenever you connect it, you have to connect it between two different columns. So you can drag and drop it like this. So I'll just place it here, and then we'll select the diode LED. Here you can find it, the LED here. So the default is red, but you can change the color here. And also for breadboard, you can just name it. I don't think you can do anything else. For diode, you can name it and you can select the color. Okay. So now, as I said, you have to place it between two different colors. So in this simulator, it doesn't let you place it in the same column, but if you are doing hands-on, sorry, same row, but if you are doing hands-on, you will be able to place it in the same row, and then you can experiment that the diode doesn't work. But here anyways, I have to place it in between two different rows. And now if you see, the diode has a cathode and it has a anode. So we'll come to it. The anode is the point that will accept the current, and diode is the point that will leave the current. So now we will just select a power supply. So here is the power supply, and you may see it has a positive terminal and a negative terminal. So positive goes to anode, so we'll link it to anode. So this is the wire, this is a wire, and we can select the color of the wire from here. So let's say I'll just select it green, and then I had to connect the other point to cathode. Again, let me change the color of this wire so that we are able to distinguish correctly. So the yellow is the one that's connecting negative to cathode, and green is the one that's connecting positive to anode. So now what we'll do is we will start the simulation and then vary the voltage and then see if it turns on or not. So by default the voltage is 5. Let's reduce it to, let's say, just 1. Okay, let's reduce the current. Okay, let's just look at the chart once. So as per the chart, the red needs a voltage drop of 1.6. So it may vary from chart to chart. Some charts might say 1.8, some charts might say 1.6. If we see this chart, okay, it's not seeing here. Okay, let's find out some more charts. Let's go to, let's say, this chart. Yep, as you say here, it's saying 1.8. So let's stick to 1.8 because in my experience 1.8 is the ideal current. Let's just keep it 5 because ideally I'm not sure what should be the current if I am changing it from 5 to 1. So I'll just keep it at 5 and we'll start the simulation. And if you see at 5 volts, it's saying the LED current is 483 milliamperes while absolute maximum is 20.0 amperes. So what it means is it's taking much more than required. So ideally I'm not able to get a proper chart. Let me check. Let me look out for some more charts. Okay, maybe this one is a proper one. No, okay. Okay, let's refer this chart only. So for red, it's saying 1.6 to 2.0. That means the voltage should not go above 2.0. So in real world, if the voltage goes above 2.0, it goes to 2.1, 2.2, 2.3, the diode will eventually burn because it won't be able to take so much current and thus a lot of heat will be produced. So it won't be able to handle that much voltage. And below 1.6 or 1.8, whatever is the corresponding number, it should not blink. But in real time, what you will see is even if the chart is saying 1.8 or 1.6, the LED might start blinking at lower values than that. So if the chart is saying 1.8, the LED might start blinking at 1.75 or 1.7. But in the simulator, as it's done programmatically, so it might blink at exactly the same value. So now let us just turn the voltage drastically. Okay, now if you see, it's not blinking. We are at 0 volts. Now it's increased it slightly. It's at 400 millivolts. So now it's at 1.20 volt. It's not blinking. Okay, now it blink. Let's try to control the voltage a bit. So if you see at 1.9 it's blinking, at 1.8 it's not blinking. So the threshold might be at 1.9 for this one. So again, if you buy these diodes in the real time, you will get to know the exact input value from the manufacturing chart. It might vary from manufacturer to manufacturer. So here it seems the threshold value is at 1.9 because if I decrease it slightly below 1.9, even if I keep it at, let's say, 1.7 or 1.8, it's not blinking, but at 1.9 it's blinking. Okay, here it's giving us a fine blink at red. Even at 2.3 it's blinking. Let's try to increase more. Okay, now it's giving us a warning sign. So let's try to figure out at what voltage it gives us a warning sign. I'm trying to increase it more slowly. Okay, I think at around 2.8 or maybe at 2.7 it was giving us a warning sign that the voltage is too much. Let's refer the chart again. Where is the chart? So it was saying around 2.0. So yeah, I think the chart values are slightly different than what this simulator is using. As I said, the manufacturer might use different thresholds, so you will always be able to figure those thresholds if you buy a real diode. But if you're using a simulator, maybe you can just play around with what is the threshold. um, I would suggest to use a simulator because I think the simulators are quite advanced, and it gives you a quite a fair idea how to design a circuit. So this was just a basic circuit, basic diode LED circuit. Now in coming videos we'll design some more complicated circuit, but to design those circuits it's quite important to understand the basics first. So thanks for watching.